Okay, so we have one current that is going into the page. And using the right-hand rule, we can see that we have a magnetic field that is going in the clockwise direction. Our second current is coming out of the page. Using the right-hand rule again, we see that we have a current going in the counterclockwise direction. These are a magnetic field going counterclockwise direction. These two magnetic fields in the center combined have a net magnitude that's upwards, but because this magnetic field is stronger, there's going to be a point to the left of this weaker magnetic field where its influence will cancel each other out, and there will be a point where there will be zero magnetic field.
So after we find the general location of the point where the total magnetic field is 0 in part A, we found it to be to the left of wire 1, so we just know that it's somewhere over here. And then, so when we apply these concepts to an actual formula, we go over to this formula over here, which is the magnetic field of the wire is equal to mu naught times our current over 2 pi r. But we can actually just remove the mu and the 2 pi because they're constants. So we just have magnetic field of the wire is equal to current over the distance.
Okay, so now that we have the equation for the magnetic field and we have it as I over R, and we have two currents, we can set up a proportion of I1 over R equals I2 over R.
Now that we know that the 0 point is to the left of I1, we know I1 is equal to 2 and that I2 is equal to 4. We can use I over R and figure out that 2 over R and 4 over R plus 6 in order to solve for R will lead us to R also being 6 centimeters, meaning the 0 point is 6 centimeters away from I1.